So here we have the example that says, according to Harris International, 58% of all adult Americans believe that divorce is acceptable. In a random sample of 500 adult Americans, determine the mean and the standard deviation number of adult Americans who believe divorce is acceptable. Well, before we go on and apply the formulas for our binomial distribution, we first have to verify that this is, in fact, met the requirements for a binomial distribution. And that's what we were looking at previously. One, are there a fixed number of trials? Hopefully you see that yes, there are a sample size of 500, so that's my fixed number of trials. Do I have independence here? Well, we're talking about people here, adult Americans, so the idea of one person thinking that divorce is acceptable is independent of another person. I would also say that my sample size N, 500 adults, has got to be less than 5% of all adult Americans. So we're good to go on that one as well. Number 3, are there 2 outcomes? Yes, there are 2 outcomes. That would be acceptable or not. And number 4, are the probabilities the same for each of the trials? What's the probability of finding someone who believes divorce is acceptable? Well, that's 58%. So P, the probability of success, in this case we're looking for acceptable, divorce is acceptable. The probability of success, P, is equal to 0.58. And again, I'm going to be converting all of my percentages into decimals in order to apply them in my formulas. So this next bullet here says go ahead and find the mean and interpret it, as well as finding the standard deviation. So to find the mean, mu sub x, right? So the mean of my variable x, which are the number of Americans who believe divorce is acceptable, can be found by multiplying my sample size times p, or 500 times 0.58. Multiply those 2 numbers out, and to the nearest whole number, you should get 290. Now, while we're here, let's go ahead and find our standard deviation of our variable. We're going to take the square root of NP, 1 minus P. So that's going to be the square root of 500 times 0.58 times 1 minus 0.58. I'm going to use this free online calculator. I'm using the scientific version of it, and it can be found at desmos.com. And I'm choosing the scientific calculator to calculate the standard deviation. So I'm going to take the square root of 500 times 0.58 times, and I can just put a parentheses here, 1 minus 0.58, close my parentheses, and you'll see that I have approximately 11 for my nearest whole number. So back over here, I have found that to be 11. So I have both the mean and the standard deviation calculated. Now let's interpret, what does it mean? What does our mean, the 290, actually mean? So here I have it written in blue. Our mean is our average that we would expect to have happen in the long run. So assuming 58% of adult Americans believe divorce is acceptable, we expect approximately 290 in 500 people to find divorce acceptable. So if 58% of the population find a divorce acceptable, and I have a sample size of 500, then the proportion of people, then 58% of 500 is the 290. So we kind of say on average, we would expect 290 out of 500 people to find divorce acceptable, given a population that says 58% of the population who says divorce is acceptable. Okay, so you want to work on understanding that interpretation right there. Now, the second thing that we want to do is I want to calculate what is the probability of finding at least 275 people who believe divorce is acceptable. Well, before we go into that calculation, I want to first back up for just a moment. We were just calculating, I'll pull it down here, mean and standard deviation. And we said back in chapter 3, in order to apply mean and standard deviation, I have to be looking at a distribution that is normal in its shape. So I've drawn a bell curve here, and we remember that in the middle of that curve is our mean. So here's our mean, and we calculated that mean for this problem to be 290 people. And then, of course, we have our standard deviation of 11. Now, I want to know what's the probability, capital P, of finding at least 275 people. Well, X is our variable for success. So X is the number of people who believe divorce is acceptable. And I want to know at least 275. So that's going to be 275 or more. My symbol would be greater than or equal to 275. So the probability of finding 275 or more people who believe divorce is acceptable. Well, this is a probability question that I don't really know how to calculate based on the given information. So we're going to use a calculator specifically designed for this process in StatCrunch. And the reason I have gone to the trouble of drawing this normal curve over here or the bell shape over here on the left is because my drawing here is going to be supporting my conclusion in the calculator. So I'm going to add one more thing to this graph, and that's going to be my variable X, that's 275. So if I were to put somewhere on this graph, remember that the horizontal axis here, or the bottom axis, represents the people who believe divorce is acceptable, the number of people. And we're focusing in on 275. So 275 is going to be to the left of 290, and I am interested in 275 or more. So I'm interested in all of these people that are to the right of 275. Now, what the calculator is going to tell me is how much of this area is shaded. What's the area under that curve? So we're going to go to StatCrunch, and I'm going to go to Stat, Calculators, Binomial, because we're looking at a binomial distribution. So here's the calculator that I'm interested in. And notice here I have an option to put my sample size. So I'm going to put the sample size. Let's see if we can back that up. I'm looking at a sample size of 500. And I have a P of 0.58. And then down here on the second row, I've got my probability statement that we were looking at. We said we were looking for probabilities that were greater than or equal to 275. So 275. And you can see here that this number, 0.9195, is the probability of encountering 275 or more people out of the 500 who believe that divorce is acceptable. So StatCrunch is giving me this probability, and that's always going to fall in this blank to the right of the equal sign. The 275 that I put in there is my variable amount I'm looking for. Now, one other thing I would point out here, do you notice that the color, here I have a normal distribution curve that we were just drawing on our own paper, and I have two colors, I have a red and a black. And I hope you notice that this separating line between the black lines to the left and the red lines to the right is that 275 number that we're using. So for StatCrunch, when I have an area that's shaded red, that would be, in our question in this particular chapter, that's the success. That's what we're looking for. So this area that's shaded to the right, or that's all colored red to the right of what my 275 is similar to our area that we shaded over here. And the reason that I like my students to draw it and then shade it is because it helps you identify the right inequality symbol, because sometimes we get in a hurry, we may have changed our inequality symbol. So here I made it less than, and you can see that if I'm looking for areas that are red, that's not the area that I shaded on my own paper. So it's kind of a way for me to double check what I'm doing. So we found that the likelihood or the probability of finding 275 or more people who believe divorce is acceptable is around 0.92. So I'm going to put that here on the paper, 0.92. Now, how do I interpret that probability? Well, we might be able to say that in 100 trials, remember we're going to use the last place value there, in 100 trials of this study, so this study of 500 people, we expect about 92 of those trials to result in at least 275 adult Americans who believe divorce is acceptable. So let me say that a different way. If I were to repeat this experiment 100 times using the exact same sample size of 500, 92 of those repetitions are going to result in 275 or more people believing divorce is acceptable. So that's how we interpret this probability. Remember, we were practicing interpreting probability back in chapter 5, and we're going to continue to be able to interpret it here in chapter 6. So the next question that I want to ask in this particular example, what's the probability of exactly 310 who believe divorce is acceptable? So what's the probability that my variable x, those are the people that believe divorce is acceptable, is exactly 310? That means equals 310. So I don't know this probability. This is not something I can calculate. I'm going to have to go to my calculator that's in StatCrunch. The sample size is still the same for this question. The probability of success is still the same, but we're going to change my inequality symbol to an equal sign, and I'm going to change this to 310. Hit compute, and you can see here that the probability of getting exactly 310 people out of the 500 is at 0.006. So 0.006. And how would I interpret that? When I interpret it, it might look something like this. In 1,000 trials this time, remember we're letting that number be our place value, and I should have rounded up to 7. In 1,000 trials of this study, we expect 7 of them to result in exactly 310 adult Americans who believe divorce is acceptable. So remember, when we're thinking about interpreting probability, it's a repetition of the exact same thing I was doing. So here I had a sample of 500 people. If I repeat sampling 500 people 1,000 different times, 7 of those repetitions will result in exactly 310 adult Americans who believe divorce is acceptable.